applied geochemistry with case studies on geological formations, exploration techniques, and environmental issues. This course is brought to you by Gilad James Mystery School. Learn more at giladjames.com. Introduction. The Arabian-Nubian Shield, ANS, forms one of the largest exposures of juvenile continental crust, 1,000 to 525 ma, on Earth. It consists of mainly juvenile Neoproterozoic crust, now widely exposed in parts of Egypt, Saudi Arabia, Sudan, Eritrea, Ethiopia, Yemen, and Somalia. The ANS was formed during the Neoproterozoic between 900 and 550 ma through the accretion of intra-oceanic arcs during the closure of the Mozambique Ocean and the amalgamation of Gondwana. These accretion processes led to the formation of well-defined arc and continent arc suture zones. The ANS was essentially stable continental crust by Early Cambrian time at 530 ma. The ANS and its surroundings has been the object of geologic investigations for a wide range of geological, economic and scientific reasons. The Precambrian basement of the Eastern Desert of Egypt, ED, is a part of the Arabian-Nubian Shield, ANS, and are exposed mainly in the Eastern Desert and Sinai. The Eastern Desert of Egypt comprises variably deformed and metamorphosed volcanic, plutonic, and sedimentary rocks of Precambrian age, unconformably overlain by Cretaceous sediments. The Eastern Desert of Egypt is classified into three domains, North, Central, and South, all revealing different aspects of the region's protracted and intense Neoproterozoic episode of deformation and igneous activity. The Central Eastern Desert, CD, preserves the oldest, Tonian Cryogenian, history and also best preserves Ediacaran deformation as well as associated, Hammamat, basins. The Southern Eastern Desert, SED, lacks BIF, Ediacaran sedimentary or volcanic successions such as the Hammamat group and Dokan volcanics, whereas the SED does not. The Northern Eastern Desert, NED, is very different than either the SED or the SED. Dokan volcanics and Hammamat molasses sediments are of widespread occurrence, whereas aphylites are absent and gneisses are rare. A. Inset geological sketch map of NE Africa showing the Arabian-Nubian Shield, the Saharan Metacraton, and Archean and Paleoproterozoic crust that was remobilized during the Neoproterozoic and, b. Geological map of the Eastern Desert of Egypt showing study areas. The reconstructions of this lecture are based on a compiled data of geochemistry and obtained ages on the rock units constituting the Eastern Desert of Egypt. Geochemical data are based on combination of major elements, trace elements, rare earth element, RE, distributions as well as isotope data. In this contribution, I build on previous geological and geochemical studies on the different rock units forming the ED for many years of research to summarize the most important geochemical characteristics of the different rock units and to provide some important information regarding the geochemical dynamic and evolution of Neoproterozoic crust of the ED. This lecture reviews the scope of current geochemical and isotopic datasets for the ANS, with particular emphasis on the Eastern Desert of Egypt.